Where's the link to use UFK? Can you just tell me that, please? Why the fuck? ನನಗೆ ಬಂದೇ ಇರೋ ನಿಮಿಷ ಊಟ ಹಾಕ್ತೀನಿ. Hope it's streaming. Can you go to the IEEE RAS page and check if it's streaming? Hello, brother. Is it streaming? Can you check? Is it streaming? Can you check? Check fast. Check. Hmm. Do you even follow them? Happening, no? Peace, no?
So, am I audible?
Yeah.
Okay. So let's start. Today's workshop on Raspberry Pi. It's a single board computer with like uh, parts like GPU and RAM and all that, which, as someone asked, the Pi Pico doesn't have. it's a there are two types: microcontroller and microprocessor. Raspberry Pi is a microprocessor with functions like uh, like it can process images and all. But Pi Pico is similar to an Arduino. It can only it has limited processing power. So there are different series of Raspberry Pis, like the original Pi 1, 2, 3, 4, Pi 0, and Pi Pico. Pi 0 is just a smaller version of the normal Pi, and there are many generations of each series. The latest generation of Raspberry is the fourth one. So Raspberry Pis have a variety of applications, and it can connect to many different sensors and actuators. So due to this feature, it can act as a IoT hub and can connect multiple sensors and together and share data. You can even use it as a normal computer, just connect it to a monitor with some keyboard and mouse and get on. So right now we're setting up a Raspberry Pi. You just need like a Raspberry Pi and a power supply of minimum 2 amps. Otherwise, it won't have enough power to run. A laptop desktop with NUS. Micro SD card is for the storage where the OS and the other stuff stays for the SD card. The newer versions of 3 and 4, they use micro SD card, but the older version 2, they use a bigger SD card version. And if your computer doesn't have an SD card reader, you can get a USB SD card reader, which you can plug into the laptop. So right now you can download the Raspberry Pi imager, this one, from this site, the official site. Once you download, you get the screen. So here you can choose OS, choose the first one. This is a default Raspberry Pi OS, and here in the settings you can set you can preset some of the settings, because before this update we had to use a monitor. Monitor was required, so you can do the first setup. Right now with this feature, we don't even need a monitor. So enable SSH, so you can remotely connect to your Raspberry Pi. And then here you can set your username or password, anything. And this here you can put your Wi-Fi, the Wi-Fi you're connected to, your phone hotspot, anything, whatever you're going to use. Set the country, and yeah. So once this is done, you can choose your SD card. If you connect it, it will show up here. Once you choose that, you can write. It will take a while, 5 to 10 minutes. So once that is done, you can just directly remove the SD card and plug it into your Raspberry Pi, power it on. After that, you can continue with what I'm going to say. Is anyone following? This is a setup that I explained right now. So here, to scan all the, we need to get the IP address of the Raspberry Pi. So right now you can scan using an Android, or I think this is also there on iPhone. So you can use this app to scan whatever devices are there on your network. It will show up like this, and you can get the IP address of the Pi. If you're on Ubuntu, you can even use ifconfig to get the the Wi-Fi card name, and then you can do this to get all the devices and then get the IP address of the Pi. These are the two options you can do. Once you get the IP address, if you're using Ubuntu, you can directly access it on the terminal, like SSH. So you can copy this IP address and then paste it here. So it'll log you in like this. If you're on a Windows device, you can use an app called Putty. Here also you can enter the IP address and connect. So it's the same thing, but I prefer to use normal terminal because there's more control. So here username is the host name you set here, and username is the one you set here. You can choose whatever you like. and IP address is the one you found over there or on the app here. So once that is done, run sudo raspberry config to enable VNC. We are going to right now what we are going to do is remote desktop into it. Have you ever used AnyDesk or TeamViewer? Is a similar case. So you can directly watch the desktop of Raspberry Pi without a monitor. So here. Get it like this. So in interface option, VNC, enable it. So right now means you can enable it like this. Once that is done, you go down and finish. So when that is done, you can install VNC viewer from here, from the official site, whatever distro you're using. From here, if you put the same IP address, you can again connect to it there. The first time it will ask you for the username and password. Since I've already done it, it directly let me. So you can easily see on the desktop of the Raspberry Pi without a monitor. So once that is done, so this basic setup of Raspberry Pi is complete. You can use Raspberry Pi without any peripheral devices directly. Right now, we learn how to use GPIO pins. These are the pins on the sides of the Raspberry Pi. There are two different ways of using the pins: GPIO board and GPIO PCM. Board is a physical board numbers, these 1, 2, 3, 4 inside the pins. So this order never changes no matter the version of the Raspberry Pi. All versions of the Raspberry Pi 3 or 4 will have the same order. But this is the PCM version, and this depends on the version of the Raspberry Pi. Each version has their own different numbers. So if you're going to work on different boards, then choose the GPIO.board method, because if you put it on a different Pi, then it won't work at all. Yeah, and you can also try this. If you don't remember the Raspberry Pi pinout, you can just type pinout in the Raspberry Pi terminal and it will show you what is the pinout diagram. So you can refer to it easily. So this is a simple LED blink program with Python on Raspberry Pi. To use the Raspberry Pi, you have to use the GPIO pins, you have to import GPIO. And here, set mode GPIO board, like I explained over here. And set up LED. So LED is one of the pins, 18. So the GPIO board pin will be this one, 18. And we are setting it to out because that pin is switching on and off the LED. And switch is an input, GPIO.in, it's inputting data from the switch if it's on or off. So for 10 times it will switch on the LED, and after like 0.2 seconds switch it off, and it'll keep repeating 10 times and just prints out the switch status if it's pressed or not. And you run another Python script that uses GPIO pin, then it won't be able to access that particular GPIO pin. If there's any doubts, you can just stop me in the middle and ask. So PWM also, like, full form is pulse width modulation. So it's basically the signal is stopped and started in bits for sending more data than normal. The normal pins, they just have two states, on and off, and PWM has a variety of ranges. So here, just a second. Yeah. So add event is a parallel threading kind of function, which which is like out of the current flow of the program. Even like after add event, the program continues to execute, and when that event is detected, it will run the callback function that is given to it. So when it detects that the switch data is going down, that is it is unpressed, then I mean when it's pressed, then it like it calls this function automatically and clears up everything and like, exits the program. If while it's not pressed, then and there's different versions of this also. GPIO falling, rising, and on off. So rising means if the input to that GPIO pin is increasing in voltage, then it will call that function. Or if it's falling, then it will call that function. So here LEDs pins are defined and they're set as output, switch is set as input, and the mode is set as board. So for each of the pins, it will set it to 50, this 50 is the frequency, 50 hertz. Pretty sure it's hertz. And this 0 here is duty cycle. So duty cycle is the percentage of time that is that the signal is on. So 50% duty cycle means in 1 second the signal is on 50% of the time and is off 50% of the time. It's in a square wave format. So duty cycle is 10, then 10% of the time it's on and 90 is off. So with this you can control the voltage. That's how voltage buck converter or voltage lowering boards work. So once it's started, then you can just increase duty cycle and then try different methods. Change the duty cycle, see how bright it gets and how low it gets. So this Pi serial is for communication between your Raspberry Pi and Arduino. So you can connect your Raspberry Pi to your Arduino, and if you've ever used an Arduino, then you can see that there's a serial monitor. So in serial monitor, whatever you can input and output data. So for example, installing is just simple pip install Pi serial. So here, so this port number you can see in an Arduino when you it will take time. So the port number will show up in the Arduino board, Arduino ID. So you can check it from there and put it here. Baud rate is the number of bits per second that is transferred. So whatever you set over here, so you can see the board over here, tools board. If the board is connected, I didn't connect one right now, but it will show up here. And in the beginning, whatever baud rate is set, as in code is right here. So yeah, so whatever baud rate is set over here has to be the same as over here. So otherwise the rate won't match and then the data won't transfer properly. This timeout is 0.1 seconds. And then you can this function will start over here. This infinite loop will like take a input value from the user on the Raspberry Pi, and once it's read, it will send it to the Arduino here, and then the Arduino code here will read it and then print it back, and it keeps like looping around. It doesn't loop around; it just prints it on the Arduino serial monitor. You can see over there. Yeah, it just prints it. Okay, it doesn't show up because the board is not connected, but monitor will show up. You can press it. It'll whatever you type in the Raspberry Pi, it'll send it to the Arduino and show up in the serial monitor. And right now the web server. So if you set up a Raspberry Pi as a web server, then any device on the same Wi-Fi network can be accessed. For example, you set it on a PES Wi-Fi, then anyone who connected to PES element block can access the web server. So we'll be using LAMP stack for this workshop. Installation is very simple. Just apt install all of this. Just copy paste this thing, and it will install. It will install all of this. Apache 2 is for is the web server, and then MySQL MariaDB is a database, and this is for security. So here, after you install MariaDB and installation and MySQL secure installation, it will it'll run a series of configurations. So you can just read it and then understand what you want to do. So once that is done, you can run the local host on Chromium. That is the default browser on Raspberry Pi, and it will show you the default Apache web page. Yeah, so this is the default Apache 2 page. Once you replace this page with your own websites, you can like host your own websites. Since the Raspberry Pi is very small and it doesn't have too much processing power, then if too many people join in and try to access the same web server, you get very slow. Yeah, so once that is done, your web server is set up, and right now the problem statement that you'll be given is to host a website, any website you want, something like e-commerce site, Amazon, or blog site. So if you don't have a Raspberry Pi, you can use a VM or a dual boot Ubuntu and then run this command, and then I'll provide a this link. With this link, there's a tutorial on how to run the web server and replace it with your own websites and all. So you can refer to that and create your own web server and access it from other devices on the same network. That is a problem statement for today. Are there any doubts till now?
Excuse me, could you repeat without Raspberry Pi, what should I do?
Yeah, sure. Do you have an Ubuntu VM at the moment?
I'm dual booted my systems. I'm using 20.0.
Okay, fine. If you're dual booted, it's fine. Just copy these 4 commands. I'll send it to you after this workshop. Just run the same way I ran it here. So you can just run it over here. It'll install whatever is required, and then.
Could you show that for just a second?
Okay, the command.
Yeah.
Okay, I'll just put it in this.
Okay.
Yeah, so just run these 4 and it'll install whatever is required, and then type HTTP like this link. It'll open the default page of Apache. So once that is once that shows up, then your installation is successful, and you can continue referring to the link I'll provide you in a while to solve your problem statement.
Okay, what do we do after running these 4 commands?
Yeah, so after the 4 commands are run, then your Apache installation is complete. To verify if it's correct or not, just open this link in Firefox or any browser you want, and if it shows the default Apache page like this, then it's successful. Any other doubts? So basically, I'll run through the setup part very quickly again. So install Raspberry Pi imager, and then choose the OS you want, connect your SD card, and then choose the storage here, enable all the settings and then change it to whatever you require, the Wi-Fi and username, password, and then write it. It will take like 5-10 minutes. And once that is done, insert into your Raspberry Pi, power it on, and then SSH into it using Fing or this a Linux command scan. You can get the IP address of the thing, then SSH into it with this command, or if you're on Windows, then you can use putty and connect to it. Once that is done, you can run Raspberry config, switch on VNC access through Raspberry config, and then you can put that IP address over here, and you can access like a normal desktop computer with the server. So right now the Pi image is I've used is the light one. So this installs only the basic Raspberry Pi without any other desktop like other applications. So Raspberry Pi full will install everything. It's much bigger, like more than double the size. It has all the apps like LibreOffice, the writer, and all that stuff. So if you're not going to use it as a desktop, then go for the basic one. It's much lighter. If you want to use it as a server, then Raspberry Pi Lite doesn't have a desktop environment like this one. So if you use that, it'll be much lighter and faster, but it won't have a desktop interface. You'll have to do everything through terminal SSH. Any other doubts in GPIO pins or anything? I think that's it. Is there anything else you want to know about Raspberry Pi? Just a second, I'll just see if there's anything else. And the problem statement is due by 8 p.m. tomorrow again. Right now, I think Aditya will teach you about how to install VMs. You can let him take over. Okay, he'll come back in 5 minutes. Okay, wait for 5 minutes. If there's any doubts, ask.
There was a HTTP link, right, to verify something. Could you go back to that slide, please? Oh, okay, thanks.
Yeah, so it's just the once Apache is installed, it will run on localhost. Localhost is basically the IP address of the Pi only. Then so localhost, you can put the IP address of the Pi. It's the same thing. By default, Apache runs it on the localhost, and you can just go to that link to check if it works or not. The default web page is there or not.
Excuse me.
Yeah.
What do I do for this question? Remove anonymous users.
Could you repeat that?
Remove anonymous users when I did the last command, sudo MySQL secure installation.
Okay. For now, just say no.
Yeah, remove anonymous users. No. Okay.
No.
Then just 1 second. Disallow root.
Just say no for everything right now.
Okay.
I think at the end, for reload privilege access, the last one, just say yes. Everything else you do no for now. If you want to change in the future, just run the command again. It will run the.
That reload privilege also I put no. What do I do now?
It's fine. Just do this thing. Sudo Apache thing for this file.
Just sudo.
If I did something.
Okay. And then.
Okay, just a second. Yeah, just do this sudo service Apache to restart. It'll restart Apache and then. Anyway, right now you're not using the MySQL part at the moment. So once you restart your system, it will run it again. Anyway, if you run the 4 commands again, it will run the whole this whole configuration again. So if you want to redo it, then just run it again and redo it properly. In 5 minutes, Aditya will teach you how to install VMs and use it for.
Oh, Pratham, are you done with the workshop?
Yeah, you can take over.
Okay, cool. Okay. Is my screen visible to everyone?
Yeah, it is.
Okay, cool. So for this workshop and for the next ROS workshop, you have to execute everything on Ubuntu. Okay. Basically, it's like see, right now you have a Windows machine. All your commands will only run on Ubuntu, whatever Pratham shared with you. Okay. So for that, there are two ways to install Ubuntu. One will be to install a virtual machine on your laptop, so you won't be risking anything, and it will run on your Windows machine itself. Other way is to dual boot, basically installing two OSs. Okay, so right now for this workshop and for the ROS workshop, virtual machine is more than enough to work with this. But keep in mind that for the what do you say, the final hackathon, this virtual machine might not be enough because of power constraints or whatever. Okay, right now I'll just tell you guys how to install a VM. I've already shared a drive link with you guys on WhatsApp. Okay, and I expect you guys to download these three files. Okay, and keep it ready. Okay, now after you downloaded all this, you should have three files on your desktop. Okay, run the first one. Okay, I'm not going to run it because I have a newer version installed on mine. Basically, just run it, whatever affirmative options you find, yes, accept, or whatever. Just do that. Once you have it ready, you can open up VirtualBox like so. Okay, yours might look a little different. Okay, you won't have all these VMs in here. 1 second. Am I audible?
Yeah, you're.
Okay, cool. Okay, so once you have the VM ready, now run the second file. I've put all the instructions on the WhatsApp group. Okay, again, run the second file. It's going to ask you to, again, whatever affirmative this thing is there, just select that. Default settings. You don't need to change anything. Okay, once you're done with this part, lastly, just run this drone programming IO, voila, this one. Again, you don't need to change anything in here. Just go on, click on finish or whatever is the yeah, whatever default settings are there. Just click on that and next, and okay. Okay, after you're done with this whole part, you should have a entry like this. Okay, it should be drone programming IO or whatever. Just double click on that to start up your VM. Okay, this is just a substitute for the Raspberry Pi, whatever they're using. But in your final hackathon, you guys are expected to use the Raspberry Pi hardware itself if your problem statement requires it. Is everything clear so far? Okay, this will be your Ubuntu, what do you say, OS. Now, whatever commands Pratham told you, you can open up the terminal and start running it here. I think it was sudo, 1 second. You just copy from here. Yeah, if it asks for password anywhere, the password is the number 1. Okay, you will need this for the next ROS workshop also. So try to download and keep everything ready then. The Gokul will teach you how to install ROS on this. So just keep this ready. This is all you have to do for the installation for this part. Okay, any doubts?
Yeah, hi. I'm not able to install the drone management thing.
Which one?
The the virtual machine you sent of the drone, the .ow, the OVA file.
Huh. What does it show? Can you send a
This
screenshot?
network error failed, no permission, something. I'm able to install the other file, but not the dot.
Send a screenshot on WhatsApp or something, no?
Okay. No, it just says failed network error. I'm able to install the other two.
Were you able to download it firstly?
No, I did. That also failed.
Check your network connection, no? Again, don't worry about the name, okay? It's from a different workshop that we conducted. Just use the VM for this one also. Biru, is your thing resolved? Does anyone have any other doubts? Pratham, did you tell them about the assignments?
Yeah, I told them it's due tomorrow 8 p.m. The
Okay.
assignment was setting up a website on Apache web server. The links will be
cool.
provided.
Okay. The next workshop will be starting at 1 second. Just give me 1 second. Next workshop will be starting at 9 p.m. In that time, try to get the VM installed and yeah, let me know if there are any doubts. Just put it on the group, okay? Don't DM people. Okay, I think this thing is done. If you guys have any doubts, you can stay back. Otherwise, you're free to leave.
Excuse me, will the instructions for the assignment be sent like it was yesterday?
Yeah, it will be sent. I'll send you the resources that are required on the question itself.
Okay. Okay, thank
I'll
you.
send you in like 10-15 minutes.
Okay, thank you.
Also, guys, IoT assignment is due in another 1.5 hours. Try to get it done.
Yeah, for the circuit, where should we do it exactly?
1 second. Is Rashmi on the call? Okay, 1 second. I'll check and let you know. Bro, I think she's texting on the group itself. You can ask her doubts there. Anything with respect to the Raspberry Pi workshop or the installation part, you can ask now.